Standard 12 Chemistry Unit 9 Coordination Compounds Part 3. Last time we had discussed about types of ligands. Ligands, that means ions or molecule bound to the central metal atom in a coordination compound or complexes, and it is called ligands. Here we discuss about ambidented ligands. Have a look at this example. NO2 minus, it is called nitrite ion, but as per ligands it is called nitrito. Here in this nitrite ion, one oxygen atom which is bonded with nitrogen atom by double bond, and here this by single bond. The electron pair which is donated to the metal atom by nitrogen. Electron pair donated by nitrogen atom, so it is named as nitrito N. While here in another case, the electron pair which is donated by oxygen atom, electron pair donated by oxygen atom to the metal atom or central atom, so it is named as nitrito O. It is named as nitrito O. So here in this case the ligand has two different name, nitrito N and second is nitrito O. This is the first example. Now the second example, in case of thiocyanate ion SCN minus, it is thiocyanate ion. In case of ligand, it is named as thiocyanato. So O suffix is ato. Okay. Here in this case, electron pair donated by sulfur, so it is named as thiocyanato S. And here the electron pair donated to the central metal atom by nitrogen, electron pair donated by nitrogen, so it is named as thiocyanato N. So thiocyanato ligand has two different names. One is thiocyanato S and second is thiocyanato N. From these two examples, we can say the ligand which has two different donor atom. Here in this case sulfur and the nitrogen, two different donor atoms, and either of two ligands in the complex. Here the two ligands, and it is called Ambidentate Ligands. Second thing is here, if NO plus only, so it is named as nitrosonium ion, and if it is NO3 minus, it is named as nitrate ion, and here the NO2 minus is nitrite ion. Now the another term is coordination number. The number of ligand donor atoms to which metal is directly bonded, and it is called coordination number. For example, CONH3 6 times, charge is 3 plus, and for balancing here 3 Cl minus for the charge balance only. Here in case of cobalt NH3 6 is the complex. So here the cobalt the 4 ammonia molecule, and the another two molecules of ammonia, here one ammonia is which is bonded with another 4 molecule, and this ammonia molecule which is bonded with another 4 so it is the octahedral geometry. and each one has 90 degree. There they are stands at 90 degree. Okay, this also. Here the coordination number of cobalt, that is 6. Coordination number is 6. Now the another example is NiCO4 nickel tetra carbonyl. Here the central metal atom is nickel. This wedge structure. This cobalt. So it is carbonyl. Here the 4 carbonyl group which is bonded with nickel central atom. Its coordination number is 4 and they are in tetrahedral shape. And second thing is very most important here, as note, the coordination number is considered only by number of sigma bond form. If in some cases there is double bond, so here the pi bond is formed. So pi bond is not considered as coordination number. They considered only the sigma bond formation. So by number of sigma bond formed by ligand with central atom. So in short, here the number of ligand donor atoms to which metal is directly bonded, and that is equal to their secondary valence. Now the next term is coordination sphere. Or it is in a square bracket. The central metal atom or ion and ligand attached to it are enclosed in square bracket, and they are collectively named as coordination sphere. For example, K4, and here the in square bracket FeCN 6 and its charge is 4 minus. So this entity which is written in a square bracket, so it is called coordination sphere. And the species which is written outside of the square bracket, it is called counter ion. And the counter ion which is ionizable, while the coordination species which is written into square bracket is non ionizable, or they are not dissociated. The next term, that is coordination polyhedron. They are octahedral, tetrahedral, square planar, trigonal, bipyramidal, and the square pyramidal. Here the for example, cobalt NH3 6, charge is plus 3. Here the NH3 4 NH3, and they are in octahedral shape. These two ammonia, one, two, three, 4. This 1, 2, 3, and 4. So it is octahedral in shape, and their coordination number is 6. And here the another coordination entity, nickel, and here the two carbonyl which is in same plane. It is the front side and is the back side of the plane. So this shape is tetrahedral, and this 4 carbonyl group which is bonded with nickel its coordination number is 4. And then after the another example, PtCl4 2 minus, here the 4 chlorine, hence it is bonded with platinum metal, and this shape is square planar, is the metal and the 4 ligands. Now in case of trigonal bipyramidal, most ofly the trigonal pyramidal in Ml5 types of complexes, M for metal and L for is metal atom, or L stands for ligands. For example, FeCO5, or here for general structure, the 2 ligands, and here the 3rd ligand, and the another 2 ligands. Here these ligands here 1 2 3, these ligands which is 1 2 and 3. It is trigonal bipyramidal, and here M stands for Fe and 5 ligands stands for carbonyl. Now the square pyramidal, this also Ml5 types of metal, and the 4 ligands, here the 5th ligand, 1 2 3 and the 4. And for example, VO AC twice. Here the AC is acetyl and this written as AC, and this AC stands for acetato, also written as AC. And then after, the another term is oxidation number of central atom. It's important for MCQ. For example, COCl2 NH3 4 square bracket over Cl. We have to find out the oxidation number of cobalt. So it is assumed as X. So as per calculation of oxidation number X, and here twice Cl and 4 plus 4 molecule of ammonia, and then plus here the Cl, and their total is stands for 0. Here the no charge, so it is stands for 0 X. Now for Cl minus 1, and here the neutral molecule and its oxidation number is 0, and here for Cl equal to minus 1. So therefore X equal to minus 2, here this 0 minus 1 equal to 0, therefore X minus 3 equal to 0, therefore X equal to plus 3. So X stands for cobalt, its oxidation number is plus 3. Now the another example, K4 FeCN6, and F is central metal atom, so their coordinate oxidation number assumed as X. Here the 4K plus Fe plus 6 of Cn, and their total becomes 0. For potassium, its oxidation number is plus 1. For Fe, it is X, and C, and cyanide ion for minus 1 equal to 0. Therefore 4 plus X, and here the minus 6 equal to 0. X minus 2 equal to 0. Therefore X equal to plus 2. Therefore X stands for Fe. Oxidation number of Fe is plus 2. Now the next concept is about homoleptic complex and heteroleptic complex. For example, K4 FeCN6, here this same type of ligand which is bound to the central metal atom, the same type or kind of ligand bound to the central atom, and it is called homoleptic complex. For heteroleptic complex, the example here, the cobalt NH3 4 Cl2 plus. Here the two different types of ligand which is bound to the cobalt. So it is heteroleptic complex. So if different types or kind of donor group, and it is called ligand bound to central metal atom, and it is called heteroleptic complex. For homoleptic complex and heteroleptic complex, the another example is cobalt En ethylene diamine thrice, here Cl3. So here the same kind of ligand is bound to the cobalt, so it is homoleptic. Another example K4 FeCN6. Here the only this cyanide ligand is bound to the Fe, so it is homoleptic. CONH3 6 that we have already discussed. In case of heteroleptic complexes, COCl2 En twice Br. Here the Cl and ethylene diamine, two different types of ligands, because here Cl is unidentate, and here the ethylene diamine which is didentate ligand. So two different kind of ligand bonded to the central metal atom, so it is heteroleptic complexes. This is most important for MCQ. Sometimes you will be asked which one of the following is homoleptic complex or heteroleptic complex. So here the basic difference between the two complexes, here the unidentate and didentate complexes which is bound to the central metal atom, so that's why it is called heteroleptic. And here the same kind of ligand bound to the central metal atom, so it is homoleptic. Here the another example COCl2 NH3 4 Cl. So here it is unidentate, it is also unidentate, but the different kind of ligand, so it is in case of heteroleptic complex. Okay friends, this is the concept about the different terms of coordination compounds. Next time we will discuss the IUPAC nomenclature of coordination compound. Thank you very much.